Wow, 1-7 already. We're getting to the end of the chapter. 1-7 is about data and spread. There's some key language in this one that you'll want to know about. We've got the terms of range, mean absolute deviation, symmetric, skewed right, skewed left, and uniform. Range in this context is the range of a data set. The range is the maximum to the minimum. What's the absolute value of that? So how far apart are they numerically? That's our range. Pretty straightforward. It may be presented as a uh, um, it may be presented as an inequality, much like we did for the window of a graphing calculator. We can present the range as being between two numbers or from one number to another, and you can see that on page 48. Mean absolute deviation I'll come back to in just a second. Wanted to get to the end of this, to the idea of skew. When we have a distribution of data, you've got a population that has occurred. We have different ways we can describe it. The first way is to describe it as symmetric. And that really means that the tails on the curve are the same. So we come up and we kind of tail off in the same way in either direction. That's a symmetric distribution. Skewed to the right means the tail is elongated going to the right. Skewed to the left means the tail is elongated moving to the left. Uniform is what it sounds like. It's a flat distribution, no deviation, no tail to it, anything like that. So that's the key part of this lesson, and effectively this is what you need to take away from this. So read it, read through it, your work is pretty much done. Wait, there's more. There's extra credit available in this particular one, and that extra credit crops up on the test. There will be a question about mean absolute deviation on the test. Should you complete it and get it correct, you'll get full credit. Should you not do it or do it incorrectly, it won't count against your score. So it's a bonus problem. It can add points to your score, and you might want to take a look at how to do it. Now, this is something that really is better done with a computer. It's from a manipulation standpoint, physical manipulation standpoint, it's somewhat hard to do with the graphing calculator, but it can be done. So if we look at this particular problem, we have what's called mean absolute deviation. And what we want to know is how far from the mean is a certain result, and then what's the absolute value of that. And if we take the mean of that absolute value, or the absolute deviation, if we take that mean, then we have a sense of the average deviation from the mean value for all of these results for a population. And that's useful in comparing results. It might be that results from one school are better than results from another, but if you look at the deviation from the mean, you find that it's quite extreme, and in fact they have much higher extremes than the other school. Could be useful in a comparison. So this is really applied math. In order to do something like this on the graphing calculator, you need to first input the data into it, and where we would go to on the graphing calculator is to the statistics screen. So we go down here, then we go over, sorry, I said statistics, I meant lists and spreadsheet, and we'll enter into there. So now we've got a list. We need to name it, and we go up here. This first line here, the first row is our label row. The second row is our formula row if we're going to do some kind of calculation then this is the row we do it in. So first we go into the label row, and yeah, we'll just call this C area. And I'm going along with the example right out of the book. And the next thing is going to be mean area, so me area. And then deviation, we'll just say div. And then abdev for absolute deviation. Not abdex, abdev. Okay. Then we've got to go through and input the data. And as I've mentioned before, this data input can be problematic in that as you do it, you might make mistakes. So it's useful to go back and check it or do it with somebody so they're kind of looking over your shoulder and reading stuff to you. So I'm going to go ahead and input this here, the 750, enter, and 700, enter. Okay. And I should have 15 data points because there's 17 here. Take away 2 is 15. So I got 15, so I'm probably feeling like I'm okay. Wait a second. All right. So that gives me my first bit of data for this thing. I've got my data entered, and now what I want to do is I would like to find out what the mean of this is. So in the calculator, as you might expect, we could go to the catalog, or probably it's just mean, M-E-A-N, and then we put in what we want. But let's take a look at the catalog. And yeah, it is mean, so we can just select that. And I have the mean, and now what I want to do is I want to get the mean. I don't want that. I want to get the mean of this whole stack. Now this is a kind of a trick. If we use the cursor and we go up and we can select something, and at the same time we can hit control, we can go and just pretty easily select the whole stack. And again, like I said, this is much easier done in a computer than in this. And now that I've got that, I'm going to go ahead and hit enter and enter. I need an equal sign. I needed to tell it I had a function. Okay, so equals mean. All right, and the mean for this is 740. So now we want to populate everything else up here with this information. And I'd like to use the power of the spreadsheet, so I'm going to put in that cell location, and that for us was equals A17, and I hit enter and I get 740. Now I could just keep doing A17, or I can use replicate. Why didn't it? Oh, it's A31. It was increasing each one on me. I didn't want that to happen, so I'm going to have to do a equals A17. And I would keep putting that in. I'm going to go ahead and put this in. Actually, I think it might be easier in this case to just simply put in 740. If I can get it right. Okay, so I've got in my mean, and I want the deviation from that, and this is simply a straight up deviation, which is the A minus B. And so I'm going to basically go over here, I'm going to put in an equal sign, I'm going to select cell A1, and it's going to show me A1. I'm going to put in a minus sign, back to the cell, put in a minus sign, and then I'm going to select B1 and enter, and it's 10, which 750 minus 740 is 10. Now I'd like to replicate that, and again, this is for you in the calculator. You use your control button to help you do this, or do this on a computer. Okay, and so here I can see I've got my values for n, and this shows me the formula. It's equals A15 minus B15. I've just simply replicated a formula, and it gave me what I needed here. The next thing I need to do is I want the absolute deviation of this, and that's at this point pretty easy. It's simply the absolute value of what's in column C. So I'm going to go into here in the formula bar. I'm going to put in, I'm going to go here, never mind. I'm going to go here, put in equals. We know what absolute value is, ABS. I'm going to do this. I want to select the cell so that I don't want to have to type the values in. I want to be able to replicate it. So I want C1, so I got the absolute value of C1. Now I'm going to go C1. And that's 10, and I'm going to replicate this, slide on down. Okay, I've got my absolute deviation, and now I got one last thing to do. I would like to know what the mean absolute deviation is. Well, I did a mean calculation over here. Now I can go over, I can grab that one. And you could do this in Excel. This grabbing that I'm doing is something that works just great in Excel. And I also got the mean of this, which is 740, no surprise. Interestingly, the mean of this one is 0, or the mean of the deviations is 0, which kind of makes sense since we're talking about the population. And then lastly, I get my my result here. And it's in a fractional form. If I wanted to get it into a to determine what it is in terms of a decimal form, I could set about doing that. But at this point, this will work for us. So that's basically it. Mean average deviation is a lot of calculations to be done. It's best done using automation. This is outlined on page 49, but also much more briefly on page 50, which tells you what the algorithm is for doing this. Again, you're not held accountable for this other than the vocabulary. You need to know what that was. This will be extra credit on the test. Good luck with it. Looking forward to seeing you take the test and succeed with that.